in my opinion, the most immediately pressing issue, one that needs to be addressed urgently to minimize the possibility of large-scale disaster, is the escalating drive towards world war. We need strategies of de-escalation, and they need to be implemented without delay. The issue of war and peace is within our ability to control, as war is entirely a human construct. But for that to happen, we need real and authentic leadership. And that is a question we will take up in future editions of Squaring the Circle. Now, on the other hand, nature has an arsenal of forces that have repeatedly affected human civilization as well as life on Earth, often catastrophically. Within the limited perspective of the modern Hegelian zeitgeist, some of these agents of accelerated change may give the impression of being too removed from day-to-day experience to be of concern. But like the proverbial black swan occurrence, which may be considered rare, exceptional, or unpredictable, but which has the potential to profoundly and severely affect the world, society, and history in ways that could prove to be extremely challenging, if not insurmountable, to overcome. But like the black swan event that in hindsight appears to have been unavoidable, the agents of global change that can impact our world and our future are predictable and avoidable, at least with adequate preparation. It is simply a matter of priorities. As small minds jockey for control of planetary resources, and their minions obsess over things utterly trivial and inconsequential, there are larger forces at work that will determine the long-term survivability of civilization. Let's always keep in mind the admonition of the great historian Will Durant, who said, quote, "Civilization exists by geological consent, subject to change without notice." Our success as a civilization comes down to one thing: our state of mind. It is essential that we encompass the long view in our thinking, recognizing the big picture of our world and its place within the cosmos. If we refuse to be dumbed down by the instruments of secular power, we might just succeed in ascending to the next stage of human civilization. The essential attitude is summed up in the words of the 6th century BC philosopher Lao Tzu, who said this: "When men lack a sense of awe, there will be disaster." So with that in mind, let's adjourn to the command and control, and we'll take a deeper look into the factors of which we need to be cognizant. Welcome back. So to continue our discussion about the cosmic environment in which our planet is embedded, we're going to talk a little bit more about asteroids. Now, asteroids are mostly in a belt that falls between Mars and Jupiter. We'll look at a little bit of the history of that here, and then we're going to discuss some of the times that asteroids have made near misses of Earth. And there's been quite a few of them actually since I started keeping track of this back in 1988. So let's begin by defining asteroids. Okay? So an asteroid is a minor body, an object that is neither a true planet nor a comet, that orbits within the inner solar system. They are rocky, metallic, or icy bodies with no atmosphere. Sizes and shapes of asteroids vary significantly, ranging from 1 meter rocks to a dwarf planet almost 1,000 kilometers in diameter. Okay, so let's look at the first asteroid ever discovered. Giuseppe Piazza at the Palermo University discovered this asteroid on New Year's Day in 1801. He named it Sirius, and considered, as it says here, considered by some to be a dwarf planet. Now, if you look at this, you'll notice it's quite spherical. So there's an important concept here in that as you get a mass accumulated and you get more and more mass, the gravitational attraction between the particles within that mass will tend to cause the mass to take a spherical shape. Because it's well known in physics that any shape other than a sphere is going to require more energy to maintain that shape. So when you get enough gravity, it starts causing any mass to try to achieve the lowest amount of energy necessary to maintain a shape. So once you get to the size of an object about roughly here, as you can see, this is 583 miles in diameter, you're now getting enough mass to cause it to cohere and to form a spherical shape. When we look at the next object, which is Pallas, which was the second asteroid discovered, you'll notice here its average diameter is 318 miles. And you'll notice that it is assuming kind of a spherical shape, but it's still distended and distorted from being the sphericality, if you will, of Sirius. You see that? You see how much more like a sphere Sirius is, okay, than Pallas. This one was discovered by Heinrich Wilhelm Olbers in 1802. It is the third largest asteroid in the solar system. Okay, the next one that we're going to look at is Juno, and it's the third asteroid discovered on September 1st, 1804 by Carl Ludwig Harding, and it's the second largest asteroid in the solar system with a mean diameter of 254 plus or minus 2 kilometers. It's 157 miles. Now notice in this artist's conception here of it, how it's even further distended from a spherical shape. You'll notice as the asteroids get smaller, the ability to maintain a shape that deviates from the sphere will increase. So, and then up here on the left, we've got showing you orbital parameters of Juno. And Juno is the green here. And you'll see here that it just brushes by the orbit of Mars. The purple orbit is Jupiter, and like most of the Apollo asteroids, as they're called, it orbits the sun in that zone between Mars and Jupiter. Vesta, and you'll see here that Vesta is the fourth asteroid discovered on March 29th, 1807, also by Heinrich Wilhelm Olbers. It's the second largest asteroid in the solar system with a mean diameter of 326 miles. And you can see this particular image was created July 24th, 2011 by the Dawn spacecraft from a distance of 3,224 miles. It also, if you can see the whole asteroid here, you can see that it's trying to attain a spherical shape. But it just doesn't have quite enough mass to overcome the cohesiveness of the structure itself, causing it to settle into the shape of least energy requirement, which is the sphere. Okay, so in the next slide, we'll see here that this is the sizes of the first 10 asteroids to be discovered compared to the Earth's moon, which is the big gray circle. All of them to scale. The objects are left to right. The dwarf planet Ceres, right? Then Pallas, Juno, number 4 is Vesta, 5 is Astrea, 6 is Hebe, 7 is Iris, 8 is Flora, 9 is Metis, and 10 is Hygiene. The scale is 10 kilometers per pixel on the original image, though not necessarily on the reproduction here. But this gives you kind of an idea of the size of the larger asteroids out there in that belt between Mars and Jupiter. I'm going to pause for just a minute to talk about our partners over at Shippo, who may save you a significant amount of headache in your day-to-day business. We sell a variety of geometry tools and models, like our beautiful Platonic solids here at Grant & Carlson LLC. And when it comes to managing shipping, e-commerce, and returns, we've been using Shippo for over 4 page is easy to navigate, and we have enjoyed stellar technical support. If Shippo can help you with your needs, please use the code below to partner with a great company while supporting our work here at Swearing the Circle. Thanks. Now back to the show. Let's look at the evolving census of near-Earth objects, in this case asteroids. And as we saw, 1801 was the first asteroid discovered, Ceres. And in 1898, the first asteroid ever seen approaching Earth was Eros. And in 1932, the first asteroid ever seen that crossed the Earth's orbit was given the name of an Apollo-class asteroid that crosses the Earth's orbit. By 1970, about 30 near-Earth objects, or NEOs, are known. Okay. By 1990, that census has risen to 135 near-Earth objects. And by 1999, the last one that I had a date for when I created this slide, which was probably not long after 1999, you had at least 400 NEOs were known by the end of the century. The current estimated, and this is probably still 5 or 6 or 7 years old, current estimated number of near-Earth objects larger than 1 kilometer in diameter, about 1,500. Okay, let's just look at a few more that have been discovered. This is an interesting one. Bennu, it's an example of a carbonaceous asteroid discovered on the 11th of September 1999. It has an equatorial radius of 926 feet. And you can see here it's very interesting. It's likely a rubble pile asteroid. You can see it's a whole lot of debris and stuff that seems to have coalesced. Here's the asteroid Eros on the y-axis dimension 21 miles. But you can see here it's much smaller than Ceres and Pallas and so on. And it now has the privilege of maintaining a shape that's far removed from...
Yo, someone, I can't read the chat. Who is that? Is that Toadski? That big toad?
66 million years ago and wiped out the dinosaurs.
Yo, Toad, I'm still mad in Canada. Oh my god. No, dude, it's official, man. Sorry, my mic. Yo, it's brother, what's up, man? It's official, dude. It's official in China, man. How's my mic sound? Does it sound okay? Does it sound like shit? Does it sound like a $30 mic that I purchased?
So this is much larger than the asteroid.
I'm still 30 and 39 in Canada, yeah. But I'm not in Canada, man. I'm 40. We did it, boys. We did it. Oh my god. It's a huge upgrade. Thanks, man. That's good, buddy. I'm glad. I hope it sounds good. Thanks, man. Yeah, the other one was really shit. Man, my computer's just so fucking like super hot.
Some evidence that there was possibly an impact, maybe even several impacts. And there's also evidence.
Yo, thanks for being here, Toad. What's up, bro? What's up, my man? What is up, my brother?
Plateaus on the planet that occurred right around that same interval.
I heard life gets way better at 40. I hope so, man. My life is pretty good, though. I'm not gonna lie. I'm having a pretty amazing life. I'm not gonna lie. Thanks, man. What's up, bro? How you doing, man? How you doing, my brother? We're starting to get a little more comfortable streaming. We're starting to figure out shit.
1,100 feet long on its axis. Now, if something like this were to come in and to collide with the Earth, it would almost certainly fragment or disintegrate upon...
Oh, dangerous shit I did.
And what you would
yeah, well said, man. Well fucking said, actually, honestly.
Multiple impacts. It would lead to more of a, rather than like a single bullet.
Yeah, man, well said, bro. Thank you, man. Thank you for being here, buddy. Thank you for your chat. Thank you for your friendship.
1998. Asteroid 25143 hit the tower. Okay, then we have asteroid Vesta and It was discovered March 29th.
Alright, one sec. I gotta take this call. 1 second, bros.
About this one, but anyways, it's a different photograph. So
Brother.
you see, one of the interesting things is the asteroids themselves have been pelted by other asteroids.
Baby!
So that suggests a rather
How are you,
interesting
gorgeous?
violent history to many of these
How are you, beautiful?
objects that are now circling the sun out there in that
That's good.
trans-Martian orbital
1 second.
between Mars and Jupiter. Okay, the next
I'm
one.
doing great, babe. I'm doing
Asteroid
great.
site.
I'm
Asteroid
in
site
China.
was
I'm
discovered
40, my
March
love.
17th, 1852. We don't have great photographs of it, so I just used an artist's depiction, which is pretty much what it looks like. And it has two tremendously large craters on it that it's perhaps possible, you see this escarpment here, it's possible that
I'm in China. I'm 40 in China. I wanted to share this experience with you.
It's a metal-rich asteroid with a mean diameter of 140 miles. So, you're discovering, and there's going to be future podcasts about this, the amount of
Yeah, I know. I wanted to share this moment with you, my love.
asteroids.
I wanted to share this moment with you, and I'm so glad. Thank you.
That's something that's, in my opinion, worthy of discussion. Now, we have had
Thank you,
several
baby. Thank you,
episodes of
precious.
Squaring a Circle where we've been talking about the Tunguska impact up in Siberia.
Aw, thank you,
So
beautiful.
we'll review those because there's important lessons to be derived from the details of that particular impact. We know, just for recapping, that it had the force.
I want us to celebrate officially tomorrow properly too, my love. I guess I just wanted to call. I mean,
Never tested by the United
I know the
States.
connection's really bad without the without VOOV.
Utterly decimated over 800 square miles of the
On VOOV?
taiga forest.
Okay.
You'll get the, if you go back and review
Okay, I love you, babe.
particular episodes, you'll get the full picture and all of its extraordinary details. What this next slide is going to do is going to show you the size of the Tunguska object on the left compared to asteroid 2001 YB5, about which we will talk more about later because it is one of the potentially dangerous asteroids that have been identified by astronomers. So on the left now you're going to see the size of the Tunguska object, and then on the right you'll see asteroid 2001 YB5. I will mention that the year number that precedes the letter number designation is the year that it was discovered. So, here we go. Now, you can see obviously that an asteroid of this size would have tremendous destructive potential for it to strike the Earth. And unlike the Tunguska object, which was a smaller object and less dense and most likely very friable, it came into the atmosphere and exploded roughly 5 miles up above the Earth's surface. It was probably not a solidly coherent object, so it may have fragmented into many pieces just prior to its final detonation. But you can see here that 2001 YB5 is many times bigger. And an object of this size, of YB5 striking the Earth, it could wipe out an entire, in areas, let's say, roughly the size of the state of Pennsylvania or Georgia. And I'm talking about complete destruction. And it would have, if you recall from getting into our Tunguska discussion, there were global consequences. There was a global response to that impact, even to the point where there was turbulence in the atmosphere over America. There were white nights, as they were called, where people could read outside at night at midnight because the sky was so lit up. And there's several different theories for that. It might have been a small particulate.
Hi, sweetie.
Almost like an ice layer. It may have been gaseous from the ion tail that would have preceded Tunguska.
Hey, beautiful. Oh, look at you. You look so beautiful, baby.
Part of a comet. And we'll get back to that.
Yeah,
In our episode where we're going to be talking about comets and meteor streams.
Alright, baby. I'm
All right,
ready.
so now what I want to do is I want to get into talking about the phenomena of near misses. Now, when we talk about near misses on an astronomical scale, it could be
Thank you for sharing this moment.
a few thousand
Thank you for
miles
sharing
from
this
our
moment
surface up to
with me,
several
my love.
million miles. But the point of what you're about to see is that based upon, the discovery of Ceres in 1801, we didn't know anything about
In
other
China,
asteroids
yeah.
in
So
this
I'm
modern
gonna
science
celebrate
out there.
what,
Then we
36
begin this slow
hours of
process of
birthday?
discovering asteroids over the course of decades, and as a result of that,
Oh, I guess tonight I'm gonna
now know
stream.
that there's a whole lot more
So plan was
of
tonight I'm
these
gonna
objects
stream,
out there
and
than
then
anybody would even
tomorrow
imagine
I
a
want
few
to
decades
spend
ago.
it with you.
So I'm
And
entitling this section of
I
our
guess say hi
program
and
Close
spend some
Encounters
time with you.
While Mankind Sleeps. Okay? And because we are asleep,
If
in
you
a
like
sense,
that.
oblivious to the cosmic environment in which we live and exist, in which our planet exists. And one of the messages I'm trying to get out is that we need to be much more cognizant and aware of what's going on within the larger realm of our existence, because many ancient peoples that we consider pre-scientific and illiterate in the sense that they were presumably hunter-gatherers and foragers and so on, or subsistence farmers,
Yes.
paid much more attention to the sky than the average person does today and what was going on
Yeah,
in the
you're
sky.
right. It's great. Yeah,
So let's begin. I'm going to go back to March 22nd,
Yeah.
1989. Now, I got very interested in 1988, 89 with this idea of Earth impacts and the role that they may have had. And that's when I began to track these close encounters, if you want to call it that. So let's just go in and we'll see the headlines here. This was March 22nd, 1989, and this was asteroids passing a close call to Earth. Phew, Earth just dodged a big asteroid. And like I said, this is 1989. This was 4581 Asclepius. It passed Earth on March 22nd, 1989. It was 425,000 miles, which is just a whisker's breadth in cosmic terms, okay? Approximate explosive yield upon Earth impact. This
For
would be
sure,
about
big face.
600 megatons.
I've already started
This
streaming,
size now.
so but I wanted to call you to
So we have
say hi and share the
diameter of that one. Let's see.
36 hours.
So Asclepius, I don't have the diameter here, but I do have the explosive yield 600. So that means that if we go back from there, backwards, if I'll take those 600 megatons and divide it by 15, the number of megatons, so that's about 40 times more explosive than there would be in Tunguska, which then means that it was about
What does my phone say?
40 times
My phone
the
says
volume
August 2nd.
of
It's
Tunguska. Now, not diameter, but volume. Now, here's something you need to keep in mind. One of the things
you're right. I was thinking I was born in
influences how
Canada,
much
so
destructive potential an object has when it strikes the Earth is going to be its density, right? Like, for example, if I was to throw a snowball at you, it's going to be about 1 gram per cubic centimeter in density, and it hit you. Yeah, if it hit you in the face, it probably would be uncomfortable. It might sting a little bit. But if I was, and let's say that snowball is the size of a baseball. Well, now if I take the same size object, the size of a baseball, but it's cast iron, and I throw that at you and it hits you in the face, you're going to feel that a lot harder, aren't you? Now, halfway in between, let's say, a snowball and a piece of cast iron would be just a typical rock you might pick up alongside of a creek. You wouldn't want to have me throw a rock the size of a baseball at you and hit you in the head either. It would cause a lot of damage. So kind of think about that. That's kind of a loose analogy to kind of give you the idea that when we're now talking about energies released by potential impacts, and we're using Tunguska as our yardstick, bear in mind that Tunguska was a low-density object. And so the asteroids, typically like a carbonaceous asteroid, is going to be about 3 to 4 times as dense as the Tunguska object, which was almost certainly a piece of a comet, right? So if we just scale up from Tunguska in terms of just sheer energy or explosive yield, we're going to be very, very conservative because we're talking about asteroids here that could be metallic asteroids.
Yo, thank you, Toad. Thank you, brother.
Or we might might be talking about stony asteroids, which are still 3 to 4 times as dense as Tunguska. I think you get what I'm saying here. So I kind of use Tunguska as a yardstick because that's something that actually happens. We've documented it. It happened within historical times. You know, science has made numerous studies of it. So I kind of use that as a yardstick.
Thank you, man. Thank you, Toad. Thank you, brother.
One of the scientists who was looking at this object, Asclepius, he said it can come this close or closer in the future, said Henry Holt, the Northern Arizona University astrogeologist and astronomer who discovered the object in photographs taken March 31st. Then he goes on to say, sooner or later it should collide with the Earth, the Moon, or Mars, he said in a telephone interview. Kevin French, a scientist with the National Aeronautics and Space Administration, said that if an asteroid that's this size hit Earth, the impact would be equivalent to the explosion of 20,000 1-megaton hydrogen bombs. That's pretty powerful. That would be enough to totally wipe out civilization. That would be more than an all-out nuclear war. And we would be toast. Dr. French, an expert on large space objects in NASA's Solar System Exploration Division, said in an interview that such an impact would create a crater 5 miles to 10 miles wide and perhaps a mile deep. That's a big hole in the ground. But then he goes on to say that landing in the ocean could be even more destructive. Depending upon the depth of the water, the angle of entry, and size and speed of the object, it could create huge waves several hundred meters high. Waves that large could sweep over coastal areas, causing widespread destruction.
Test.
So several hundred, let's use
Test.
meters, that would be...
We're doing all right. We're doing all right.
A tsunami over 600 feet high, making as it made land.
Cody, what up, bro? Thank you, man.
This was March 22nd, 1980.
Thank you, brother.
I also mentioned that this is by no means a fully comprehensive.
We might switch levels pretty quickly. We might play some Bunker 1 essay or Dam Agent. I don't know yet. We may change the level quite quickly.
So, let's see here. August 25th, 1989.
We may change the level quickly.
Passed by Earth. Asteroid 1989, PB, also known as 4769 Castalia, is a potentially hazardous asteroid of the Apollo group. This is meaning that it crosses Earth's orbit. It is approximately 0.87 miles in diameter or 4,600 feet. Now, if you want to do a calculation, I will oftentimes just use the formula for the volume of the sphere. And, you know, obviously some asteroids are not spherical, others are. But what it does is give you kind of a ballpark. So, like, for example, you take picture any sphere, take the radius of it. Like, let's say that the Tunguska object was spherical.
Thank you for being here.
It's about 150.
Thank you for being my friend.
Diameter. That's the estimated diameter that I've seen most frequently. So that means it has about a 75-foot radius. So what you do is you cube the radius, which is easy to do if you've got a simple, like, Texas Instruments scientific calculator. You just put in the radius, 75, cube it, which is your y over x t, and then you multiply that times pi, and that times 4/3, which is just 1.333, and you're going to get the volume of that sphere in cubic feet. Now you could change it to yards if you didn't want to have or any other, meters or whatever.
Man, I really fucking suck, man.
This object, which is 4,600 feet in diameter, and its radius is going to be 2,300. Now you can imagine that when you take the cube of that radius, what it does to the number, the cube of 2,000, well, I can do it right here, so the cube of 2,300 is going to be, 1.2167 to the 10th power. So that's huge, right? Then I could divide that. I could say I'm going to divide that by 75 pi dx3 times pi times 1.333. going to see that it's many, many, many times bigger than Tunguska. So Castalia is a potentially hazardous asteroid. It was discovered August 9th, 1989.
We're gonna do a weightlifting stream maybe very soon, maybe tomorrow. No, not tomorrow, maybe Sunday. Maybe Sunday. I gotta start lifting weights, man. I gotta start doing it. I've been doing pull-ups, a lot of pull-ups on the pull-up bar, but I gotta like do weights.
It's 28,700 times more massive than the Tunguska cosmic object. Okay? Now, this was safe distance, plenty far away, you know, so there's no danger from this passage, obviously. But the thing is, it keeps circling the sun, and every time it circles the sun, it's going to cross the Earth's orbit. Now, most of the time, obviously, the Earth is not going to be at that point in its orbit when Castalia crosses it. And now, in projecting into the future, there's no known times at which Castalia
What the fuck,
in
man?
that orbit at the same moment. And thanks for that, because an object this size, again, this is going to be planetary catastrophe. Then, moving forward to November 1991, we have a near miss of the Earth by a small asteroid. This was 1991 BA, discovered January 18th. It's only 30 feet in diameter. So, that's smaller. It's smaller than the Chelyabinsk. But its closest passage to the Earth was 105,000 miles. Now, that puts it well within the orbit of the moon, less than halfway to the moon. Okay, so anytime we're talking about an asteroid passing between the Earth and the moon, they're being dangerously close to the Earth. And there's also the possibility that becoming that close to the Earth, it could be deflected in its orbit to the point where at some future orbit, it's going to be more likely to actually strike the Earth. Now,
I don't know who shot me there.
Again, it's not going to cause any serious damage. It's about half the size of the Chelyabinsk, but it would produce a hell of a light show for anybody who saw this thing coming into the atmosphere. And it would, at that site, it may or may not, I don't know the density of it, but at that size it may or may not fragment, could hit the ground, or it could burn up in the atmosphere. So this is November 28, 1991. Then we come to January 18, January 19, 1991. Then we find out that near-miss asteroid revealed as two bodies that occurred. Okay, so this was January. Let's just got a little bit out of sequence. Sorry about that. So let's just keep moving on. Okay, so jumping ahead, May 19th, 1996. All eyes on a near-miss asteroid. It was a close call for planet Earth.
I brought gears to China. I gotta change my gears.
This is 1996.
Like, look how shit my stick is. Like, it's so shit.
Very small asteroid, but so maybe no problem.
I gotta change gears.
It crosses the orbit of the Earth. NASA JPL has classified 1996 J1 as a potentially hazardous asteroid due to its predicted close passes with Earth. Discovered May 14th, only 5 days before its close passage. And notice it's 700 feet in diameter. Now, we could say that's, by cosmic terms, yes, that's small. But look here, it's 100 times larger than in volume than the Tunguska cosmic object. The energy released on impact, about 1,500 megatons. Now, the typical largest bombs, hydrogen bombs in the U.S. arsenal during the peak of the Cold War was about 1 megaton each or smaller. So imagine if you unleashed 1,500 1 megaton bombs, right? Now 1 megaton bomb is 1,000 times, roughly 1,000 times more powerful than the atomic bomb that was dropped on Hiroshima. So it gives you a sense. And this one was discovered only 5 days.
Oh, the sidestep? Oh, I suck though.
1998, asteroid.
I really suck.
August 10th, 1998 was asteroid 1998 ML14. Now it was past 1.6 million miles from the Earth, which is a nice, comfortable distance. However, it crossed Earth's orbit just 18 hours before Earth was at that point. So let's see, it was discovered June 24th, 1998. And here we go, asteroid 1998 ML14 is a stony asteroid classified as a near-Earth object of the Apollo group and a potentially hazardous asteroid. Approximately 1 kilometer in diameter. Discovered June 24th, 1998. So in the journal Astronomy Now, Jonathan Tate, science reporter, commented
This fucking
on
game,
something
man.
which I find very interesting. At midnight, Greenwich Mean Time, on August 10th, 1998, ML14 crossed the orbit of the Earth at the exact point that the latter had occupied only 18 hours earlier. Had ML14 reached that point at 6 a.m. the previous morning, an area the size of France would have been totally devastated by 6:05. Most of the world's vegetation would have been in flames by 8 o'clock, and 30 to 40% of the human race would have been dead or dying by late October. So, we can say that, 1.6 million miles, oh yes, that's safe, doesn't, plenty far away from Europe, you don't need to worry about it. But like it said here, 18 hours.
Yo, what's up, Willie Kelly?
It crossed that point 18 hours earlier. This is what happened.
Either he's from the future or a globalist shill. Alright, we'll watch it in a little bit, man. Sorry, brother, we're gonna watch it in a little bit. Willie Kelly. Thanks for following, Willie Kelly. I'll follow you back. I think you're following me.
Large asteroids cruise orbital superhighways where they someday might strike Earth, causing widespread death and destruction. Yet so far, astronomers have found only 40% of the big space rocks, each at least 0.6 miles or 1 kilometer wide. Now this is 24 years ago, right? June 22nd, 2000. We'll see how far we've come in our understanding in the last 24 years.
Wow, insane boost.
Because we know
Wow, that was fucking bullshit.
900 large asteroids. And so, here's the thing. If you're talking about generally the consensus among astrogeologists and astronomers and others who look at these kinds of events.
Willie Kelly.
1 kilometer is kind of the threshold.
It's too much.
You're talking about serious global consequences. Climate change that would last for
I like it.
2, 3, 4, 5 years or even more.
What? How?
Widespread destruction of certain regions of the Earth. Economic
This
repercussions
game,
that
man,
could
it
last for
fucking
years.
sucks.
Because for one thing, the dust
Oh my god, oh my god.
fires of an impact like this thrown into the atmosphere could cause serious global cooling. Say, for example, on the scale of the 1815 eruption of Tambora, which caused the following summer, the summer of 1816, to be the summer, the year without a summer, right? And an impact could produce the same kind of a consequence. And what you would then have is that, a lot of people would survive. Most of the Earth's population
what the
would
fuck?
survive an impact of a 1 kilometer object in the immediate aftermath. But the problem is that the secondary consequences would last for years. And with the cooling of the climate that would occur as a result of an impact like that, you would have repeated crop failures. And that is going to lead to famine. And famine then could also cause another cascading effect, which could lead to pandemics, because when people don't have enough to eat, they become malnourished, their immune systems become compromised, and then that is when opportunistic diseases and pandemics and so on can seize the opportunity.
What the fuck? Like, where did this even go, man?
Who have compromised immune systems, and this is one of the things that nobody's talking about as far as what's going on in Gaza right now. And I'm going to bring this up because we have 1 million people who are on the verge of famine. And what's going to happen is Gaza is going to become a breeding ground for pandemic diseases that could move outside of Gaza. And nobody's talking about that. And And because people aren't getting enough to eat, people are starving. Literally, people are starting to starve to death now. And so as a consequence, we're going to have hundreds of thousands, if not millions of people who are malnourished. And this famine is going to lead to serious consequences if a ceasefire is not effective and these people can be,
Like, what the fuck's that?
eating, right? We're taking a little bit of a detour here to tell a story that I think is going to be valuable. I was coming down the stairs, and I think somebody just ahead of me had spilled a little bit. My foot hit it, slid out from under me, and I tumbled down 3 or 4 stairs to the bottom. I sure banged up my left knee. It was painful, but I was very relieved to remember that I happened to pack my CBD from the gods salve. And I was really grateful that I remembered to do that. So that night I put some of the salve on, went to bed. Being in the construction and building industry, I've had many falls and injuries and stuff, and I figured I'm going to be laid up with this for a month. We drove home, I think it was 3 or 4 days later. I continued applying the salve, and I would say within a week I was getting around pretty good. I always bring the oil when I travel, but I'm now, after this episode, I'm like, okay, I'm always going to have the salve with me too. Let's go on. So October 24th, we went from June 22nd, coming up to October 24th of 2000, we get another report that the asteroid estimates are too low. And since 1991, 9 objects have come close to the Earth. Since 1991, current predictions for the number of potentially dangerous asteroids have been underestimated by at least 20%, say astronomers. According to recent calculations, there are between 750 and 900 asteroids circling the Earth.
You remembered my birthday, Willie Kelly. Thank you.
On impact. But a researcher at the U.S.-based Massachusetts
You remember the exact day.
says that these predictions could be revised upwards on the basis of new data. And the new data is just the constant...
I guess it's because I share it with Graham Hancock.
...census of objects that inhabit near Earth space. Objects on a degree that we never even imagined, a few generations ago. So this is October 24th. Now let's jump ahead to December 22nd of the year 2000. And we find that another asteroid makes close approach. Astronomers have tracked a large asteroid moving close to the Earth. The 45-meter wide or 150-foot space rock, traveling at more than 30 kilometers or 18 miles per second, came within 480,000 or 300,000 miles of the planet. That's just outside the orbit of the moon. Although this is close in astronomical terms, there was no danger of an impact. True. That's absolutely true. The asteroid made its closest approach about the zero range meantime. I guess that was a glitch. The rock has been given the name 2000 YK, and then I got the footnote that this is about the same size as the Tunguska cosmic object, which was also estimated to be about 150 feet in diameter. However, like I said, this is a rock, so this is denser than the Tunguska object, which was low density, so this would have been even more devastating. It probably would have survived its passage through the atmosphere and struck the ground, and left a hole on the same scale as the Barringer crater near Winslow, Arizona. I hope some of you have been there. It's one of the most famous craters on Earth because it's so well preserved. If you haven't put that on your list, that you can go check it out. You can certainly look it up online. Just look up Barringer crater, Arizona, Winslow. You'll find the pictures. It's about a kilometer wide, about 600 feet deep. And that was produced by a small asteroid, roughly 150 feet in diameter. Now, if something like that struck in that area, a large part of Arizona was subjected to severe consequences. Fires, hurricane-force winds traveling outwards from the point of impact, the fallback debris, which is called breccia, the fallback breccia would have ignited secondary fires, dozens of miles from the impact site. So even though this is small, 150 feet, if it struck the Earth, it would have regional consequences, severe regional consequences. So as a result of these increasing numbers of discoveries of asteroids spinning around in space, the same space now occupied by Earth, this report came out in May 7th of 2001. Scientists worry over asteroids. A group of scientists is seeking a standardized protocol for dealing with the possibility of an asteroid.
I will be honest though, it's hard to play this game without weed, bros. Like, the cannabis just puts me in such a zen state. And without the cannabis, it's just, I'm way too lucid. I tried beer yesterday, but I felt so terrible after. I'm not gonna drink any more beer. I had such a big headache waking up. It's really shit.
So yes, the call comes as interest grows in the swarm of asteroids and comets that orbit the sun in the Earth's immediate neighborhood. The concerns were sparked in part by several recent false alarms about impending impacts. Quoting one of the scientists involved, in some sense it's something we know we need to worry about, but we need to decide at what level we need to worry about it. And that's the question for everybody. And then in recent weeks,
yeah, buddy, I definitely do.
Fellow scientists Chapman and Robert Gold has been making the rounds among experts who study impact hazards. At Gold, they write in the 19th.
Yeah, I gotta change the gears, man. The gears are so bad, dude. Like, it's so bad. I brought gears though, so I'll change them.
I do believe it's still available online. It's a downloadable PDF. This is the comet asteroid impact hazard that I was just referring to. This report that came out in February of 2001. Okay, moving ahead to 2002. A huge asteroid narrowly misses Earth. Now, in intergalactic terms, it was a close shave. An asteroid capable of causing widespread devastation narrowly missed the Earth on Monday, although the nearest asteroid came to Earth was 390,000 miles. Had it arrived 4 hours earlier,
I'm just so fucking bad, man.
it would have scored a direct hit. The asteroid measured 300 meters, almost 1,000 feet, almost across, and known as 2001 YU5. Passed Earth at
there's no way.
7 a.m. For a moment, it was less than twice as far from Earth as is the Moon. And here's the thing, scientists were unaware of its approach until a month ago, when it was spotted by the American
so shit.
observatory dedicated to tracking near-Earth objects. Now, they rightfully insisted there was never any danger of a collision with Earth, but they warned that the asteroid was one of up to 400,000 small NEOs up to 1,000 meters wide that could strike the Earth with little or no warning because of the absence of an adequate early warning system. Okay? So, this is about the same asteroid, YD5, which was referenced earlier. And again, YD5 about 300 meters in diameter, 1,000 feet. An impact of an object the size of 2001 YD5 would unleash energy roughly equivalent to a global nuclear war. It could be classified as a civilization killer. Then we come up from January 7th to March 8th, and we've got that an asteroid buzzes the Earth, highlighting cosmic blind spot. An asteroid large enough to flatten the city buzzed Earth earlier this month and was not seen until after it flew harmlessly by. Got that? It had already flown by us when we discovered it. Now the object, named 2002 EM7, was probably between 48 and 80 meters, which is 130 to 260 feet. So, given, let's say, with an orbital velocity of 69,000 miles per hour, closest passage to Earth, which is just pretty much a little bit outside the apogee of the moon's orbit, which means it's just a little bit outside the farthest the moon comes from the Earth. but 1 to 5 times larger than the Tunguska cosmic object. The energy released is equivalent to Tsar-Bomba plus. Now, Tsar-Bomba was the largest hydrogen bomb ever tested by the human species on Earth back in October of '61, and it was about 50 megatons in diameter.
What is going on here?
Tons of power, and that means that it was about 3 1/3 times larger than in its energy release during explosion. About 3 1/3 times larger than the Tunguska object explosion. Okay? So, this being 130, if it's up to towards 260 feet, 130 feet in diameter, that's going to be roughly in the size of Tunguska. Double that, which it could be that much bigger. Then, yeah, you're looking at 40, 50,
Like, that's
60
fucking
megatons.
bullshit,
Now
you know.
that, you're basically wiping out the state. So then this is March 8, 2002. Let's jump forward to June 14th.
Like, this fucking game, yo.
Another asteroid, too close
Like,
for
fuck
comfort.
this stupid
Asteroid
fucking
mass
game.
within 75,000 miles of the Earth. Now that is really close. An asteroid about the size of a football field made one of the closest known approaches to Earth last Friday, June 13th, zooming by just 70,000 miles away, less than a third the distance to the moon. Okay, around 240 feet in diameter, which means that in terms of volume, it's at least 4 times larger than Tunguska cosmic object. So the energy released would be about the equivalent of a 60 megaton or more hydrogen bomb. Okay? Now, 75,000 miles, that's nothing in the cosmic sense. And here's the thing again. When an object comes that close, it can be deflected in its orbit, causing the orbit to tighten. This is what happened with Shoemaker BB9. It was undoubtedly back that struck Jupiter back in July of 1990.
Come on, man. Yo, like, fuck you. That's bullshit. It's bullshit. That's nonsense, yo. It's such nonsense.
Very important cosmic insight that was
Fucking bullshit. Like,
we saw an object pass close enough to Jupiter that Jupiter's huge gravity field was able to rip it into 21 separate pieces. And as a result of that, about 15 months later, those 21 pieces all fell into Jupiter. Extraordinary consequences. Now, that object had undoubtedly been orbiting between Jupiter and the Sun for many centuries. And most likely what happened is that each orbit it passed, Jupiter's gravity field drew it in closer and closer and closer until finally it didn't impact Jupiter, but its penultimate orbit, the gravity of Jupiter was so strong, ripped it apart. It circled the sun one more time, and now it's brought it right back in, and it collided with Jupiter. So here, a 240-foot asteroid, that's going to be, you can use the formula. Take half of that, which would be 120, raise it to the third power, and then multiply that times pi and that times 1.333, and you'll get that it's roughly 4 times larger than the Tunguska cosmic object. And very conservatively, the energy released upon impact would then be 4 times greater than Tunguska, which puts it in the 60 megaton category. And you'll see here, I think we have a video at the end of declassified.
oh, sorry, you might hear my farts. Sorry. I'm really sorry. I don't mean for that to happen.
Another report on that object said,
Let's just completely ignore that happened. No way. Sorry, man. Are you serious?
Then we come forward August
Sorry, are you
17th,
serious?
another near-miss
I'm really embarrassed.
This is by Earth, and it's an 800-meter wide asteroid. So 800 meters, okay, diameter is roughly...
I'm not, I don't support that.
2,624
I don't support that. I don't want to share that shit.
August 17th, about 1.3 times the distance to the moon. Its volume, approximately 5,000 times larger than the Tunguska cosmic object, giving us an explosive yield on impact of
Oh
approximately
my gosh.
1,000 megatons. The impact of an object this size
Share
would
that.
be a globally devastating, indefinite
Soda poop.
deceleration killer. Okay? This is August 17th, 2002. Let's jump forward to September 27th, 2003. And we have the closest asteroid yet flies past.
Oh, that's your emote.
An asteroid about the size of a small house.
I thought that was. I thought it was a Twitch emote.
88,000 kilometers. We can go 88,000, and we can multiply that times 0.621, and that'll convert it to miles. And that's only 50
Toda
over
poo.
50,000 miles, right? This is geostationary communication satellite circle at Earth at 42,000 kilometers. So less than half the distance of this thing is, satellites circling the Earth. This was 2003 SQ-222, came from inside the Earth's orbit, and so was only spotted after it had whizzed by.
Come on, man.
10 to 20 feet. Okay. Thankfully, an object that came that close was that small. Okay. Now, the smaller the objects, the more abundant they're going to be in the solar system. And as they get bigger, they become less abundant, right? But we're looking at an object here that would give a hell of a light show, but wouldn't really cause surface damage. Not the kind that we saw at, say, Chelyabinsk back in February of 2013, which caused 1,500 injuries and thousands of buildings damaged. This was an object that was about 60 feet in diameter, 70 feet right in there, and it exploded about 18, I believe it was about 15 or 18 miles up in the atmosphere. But the shock wave, when it hit the village of Chelyabinsk, was quite devastating. So then, February 24th, 2004, we had this. Earth almost put on impact alert. Astronomers have revealed how they came within minutes of alerting the world to a potential asteroid strike last month. Some scientists believe that on the 13th of January, that a 30-meter object, later designated 2004 AS1, had a 1 in 4 chance of hitting the planet within 36 hours. Now, it turned out that subsequent observations showed that it was going to be a safe miss, but nonetheless, for a little while, it looked like this object could strike the Earth. Now, this is 30 meters in diameter, so what this does is, this puts it roughly midway between Chelyabinsk and Tunguska. So, again, if this happened over a populated area, you could have tens of thousands of casualties, okay? Because Tunguska, again, luckily it happened in a very remote, uninhabited part of the Earth. The old-growth taiga forest up in Siberia.
Yeah, I'm gonna have to really change the gears in this. I have no,
However, if a Tunguska
like, really subtle movement range.
yeah, that would be like dropping a hydrogen bomb. And you would probably have hundreds of thousands, if not a few million casualties, and 5 to 10 times that many injuries. This object, halfway between Chelyabinsk and Tunguska. So then, as a result of these ongoing near misses, we had another study. Near misses raise rocky questions, just, as they should. And as I said, this is the one January 14th could have been a bad day for George Bush. It's the president was preparing to announce America's return to the moon. Now, this was, keep this in mind, 20 years ago, hey, we're going to return to the moon. But no, attacking Iraq was far more important than going to the moon, so we didn't have the funds going to the moon because we had to get embroiled in Middle Eastern wars based upon fake data, but we won't talk about that. Anyways, he was almost asked to deliver a very different message that the Earth could be struck by a devastating asteroid within 24 hours. So astronomers have revealed that during a 9-hour crisis the night before Mr. Bush's speech, they believe there was a 1 in 4 chance an asteroid would hit the planet in 36 hours. Now, even though, like I said, the clouds parted, they were able to recalculate the orbits, it's still, again, as it should have, it raised questions about our preparedness. So this is February 22nd. Fast forward to less than a month later, to the next March 19th, and we have asteroid soars past Earth, oh so closely. 100-foot diameter asteroid. So again, this is getting bigger than Chelyabinsk, not quite as big as Tunguska, but it passed only 26,500 miles above the southern Atlantic Ocean. It was the closest recorded encounter between Earth and an asteroid since Stephen Chesley, an astronomer at NASA's Jet Propulsion Laboratory. And then we move on to 2004. If you expect to be alive on April 13, 2029, you can look forward to an asteroid watching party across 3 continents like nothing the world has ever seen, because this is going to be the close passage of fate. A large asteroid is going to come very
This
close
fucking
to the
game
Earth
really
in
fucking
2029.
sucks.
Now it's not going to hit the Earth, but the question is will that close passage deflect it in its orbit enough that one of the next go-rounds it could in fact hit the Earth? We'll come back to that one in a minute, but we're going to jump forward again. I'm skipping a few years just because there's so much we can't report on all of it. We're going to jump forward now to January 29, 2008. Large asteroid zooms past the Earth with an estimated diameter of 829 feet, passed within 344,000 miles, about 1.4 times the lunar distance, on January 29, 2008. And at 829 feet, let's say 830 feet, that's going to be a radius of 415 feet. So that's going to be, again, many times more powerful than the Tunguska object of 1908. Many times. This is January 29th. Now let's jump forward a couple of months to March 2nd, 2009. And we see asteroid dodges Earth by near miss. An asteroid about the size of the one that leveled more than 800 square miles of forest in Siberia in 1908 just buzzed by the Earth. It was discovered February 27th, only 3 days before its close passage, which occurred on March 2nd at a distance of only 39,500 miles, roughly in the range of Chelyabinsk asteroid. Now as we're discovering, there are a lot of those out there about that size. Now, I'm going to jump forward again a couple of years to November 8, 2011.
Fuck this game,
asteroid
man.
2005 Y55 was discovered December 28, 2005. It passed Earth November 8, 2011 at a distance of 201,000 miles inside the orbit of the moon. Mean diameter 400 meters, which
Like,
is
fuck
like
you.
1,400 feet. So there's, do your calculation. That's your
What the
radius,
fuck is
700.
going on?
So if you're so inclined, multiply 700, raise it to the third power. Just on your calculator, you can put in 700 and hit the y-index key 3, and then you're going to go times pi and times 1.333, that is the volume per cube. Then you can divide that by put in parentheses and divide that by the radius of Tunguska, and you'll get a rough scale. This is about 800 times larger by volume than the Tunguska cosmic object. And then we have September 7th, we found asteroid will give Earth super close shave on Sunday, passed within 24,000 miles of the Earth. 50 to 82 feet in diameter, again about the size of the Chelyabinsk asteroid. If 2014 RC
What?
is closer to 82 feet in diameter, it would be 32% larger than Chelyabinsk. So the estimates were 50 to 82 feet. So if it was up there closer to 82 feet in diameter, then it would be about a third larger than Chelyabinsk and could be proportionately more damaging. Next year we'll jump forward to October 10th, 2015. A near miss of a giant asteroid 2 miles wide, traveling at 40,000 miles per hour, zooms past the Earth. Earth had a lucky escape this weekend when a huge asteroid that was heading for the planet skimmed past in what NASA has described as a near miss. Now, in this case, near miss was 25 million miles, so there was no concern of an impact. However, it's out there, or here's the thing, it's out there orbiting the sun, and it's crossing the Earth's orbit. Okay, and it's going to continue to do that. Now, if we had data on 1 or 2 or half a dozen asteroids doing that, well, we maybe could breathe easy. But what we're finding out is that the density of the population of near-Earth asteroids is orders of magnitude greater than what anybody was even imagining a few decades ago. Yeah, this thing was huge, and yeah, it would be a mass extinction event. It would certainly be a civilization killer. Jump forward to October 31st, 2015, and we have this very interesting asteroid.
What?
On Halloween, October 31st, this guy passed the Earth, resembling a skull, narrowly misses Earth. This is asteroid 2015 TB145. It was the biggest known object to pass so close to the Earth until 2027, which of course is coming up. And of course the key phrase here would be known object. Until October 10th, the Space Agency didn't even know about this asteroid. More attention was on asteroid.
That's fucked. Look at that asteroid. It's a fucking skull, man. It's really fucked.
October 29th, so get that. 2 days apart, 2 large asteroids are seen zipping through near-Earth space. One of them looks like a effing skull. This was on Halloween. Interesting. 302,000 miles, that's just outside.
That's fucked, man.
Okay, then we have coming forward.
What the fuck? It's really fucked. That's the most fucked thing I've ever seen.
Asteroid 2014 JO25, discovered May 5th, 2014. The date of closest approach to Earth, April 19th, 2017.
It's so laggy.
Closest approach to Earth, 1.1 million miles.
Come on.
So,
fuck you.
This thing here, as it turns out, is
The
nearly
lag, man.
And given the size of that, yes, 4.4 million miles could be thought of as relatively close. Because again, what we're seeing here is the increasing numbers of objects zipping through near-Earth space. Now, these objects, most of them are close to the ecliptic, which means they're orbiting the sun and are going to be regularly returning. So it's not just that they're crossing the Earth once and they're going to be gone, crossing the Earth's orbit once and they're going to be gone. No, they're going to be continually circling the sun. Now, I think what we're going to do at this point is I'm going to take a break at April 19th, 2017, and in the next episode, I'm going to carry it up to what we know at this point, and there's been some dramatic discoveries and changes in the last 7 years that we need to talk about and find out where we're at now in our understanding of our position in the cosmos. I'm taking you on a little journey, introducing you to some of the denizens that inhabit near-Earth cosmic space. Some of our cosmic neighbors, if you will.
Like, what the fuck is this nonsense,
It
man?
turns out that some of those cosmic neighbors that are moving through our neighborhood are potentially hazardous, potentially dangerous. And if you will come back to the next episode where we get it up to the present so you can get a full perspective on this, we're then going to make some suggestions about what our thinking should be about this. Once we have this greater and deeper understanding of the cosmic context of our existence, should this be something that we're
It's just so
actually
fucking
factoring
stupid.
into, say,
Like,
national or even
it's just so fucking
international
stupid.
policy? And I think the answer is going to be clearly yes, we should. This is something that actually, I think, requires an international cooperative effort. Because this is not woo, this is not science fiction, this is very, very real. And we're going to talk about what we've seen happen in the celestial realm in the last 7 years. Then we're going to take a look back at our own history. We're going to look at what geologists have discovered on the surface of the Earth, going from the number one first crater, the one I mentioned earlier, the one in just outside of Winslow, Arizona, the Behringer crater, kilometer wide, 600 feet deep. Once upon a time was the only crater known on Earth. Now, there's close to 200 craters now known, but they're undoubtedly only a fraction of the total number of craters that represent impacts of things onto space, from space onto the Earth.
I'll be back.
That we have to take away from this. With the discovery back in 1980 that 3 independent teams found evidence that the likely extinction, the most famous extinction in the history of life, the extinction of the dinosaurs, was likely triggered by a cosmic impact of an asteroid roughly 6 miles in diameter. We've learned a hell of a lot since then about the cosmic realities of our existence. Yet, what science has discovered and our policy responses have not kept pace. Here's the point, and this is something that I'm going to be arguing. In 1980, we realized that Earth was possibly impacted by huge objects from space that had caused
And my fucking chat fucking shit itself again on my thing.
By the early 1990s, once scientists had discovered the Great Crater straddling the Yucatan Peninsula that dated to precisely the same age as the dinosaur extinction, and the magic layer, the iridium layer, that pretty much settled the argument that, yeah, there really was a big impact at that point, just like we predicted. And I'm going to talk about that in more detail so we understand that and what the lessons were or are that we should be deriving from it. But the discovery of the crater followed about 10 to 12 years after the discovery of the iridium layer. With the discovery of the crater, it became apparent that, yes, this is very real. Now, interestingly, right around that same time, 1992, the Intergovernmental Panel on Climate Change released its first report on anthropogenic climate. And what we see is, in the aftermath of that, and the whole global warming scenario, we see that almost all the attention got diverted away from catastrophism in Earth history onto this idea of anthropogenically induced climate change, and that became the dominant discussion about global change. That became the dominant factor in global change. The idea of impacts, which was really beginning to take hold in scientists' mind, going, this is very real and this is a real threat. This is not sci-fi. That kind of got shunted off to the sidelines, right? Well, I'm saying now that it's time to bring it back and discuss this again, because as you'll see, what I'm going to be presenting to you in the next episode should convince you that, yes, it is real. Yes, we need to be thinking about it. Yes, we need to factor it into policies that we pursue from here on out. And also, one of the implications is that we're going to do a hell of a lot better preparing and knowing how to respond to an event like this, if not preventing it altogether, if we cooperate internationally. Yet there are factions within our own government who feel that their goals are going to be reached by through perpetual war, by demonizing other countries and making any kind of dialogue or diplomacy or cultural or scientific exchange impossible. And this is something we need to be talking about, and I intend to talk about this on Squaring the Circle. Because the fact of the matter is that one small impact is way more dangerous to our future and our children's future than a contrived enemy that is being made for political and economic gain by our own government. So I'm going to leave it there for now, but we're going to pick up this thread of discussion in the next episode, and I hope you come back for that, and we'll see you there. Thank you. I'm Randall Carlson. Over and out.
Oh my god.
For thousands of years, our ancestors have worshipped and observed the moon and its motions with extraordinary precision, building huge monuments of stone, earth, and wood to memorialize even the most subtle attributes of lunar motion. It is an ongoing mystery as to why ancient peoples all over the world were such dedicated, even obsessive, observers of the moon and its cycles. One might assume that modern scientific research would demystify the moon, its origin, and its properties. However, the opposite has happened. The more we learn about the moon, the more mysterious it becomes. Join us as we take a dive into the high strangeness of our nearest celestial neighbor. I'm Randall Carlson, and this is the Squaring the Circle podcast. Well, I would welcome everybody to another episode of Squaring the Circle, where myself and my colleague John Arthur Fiallo have been discussing our nearest neighbor, the moon, and learning about it, and what we're finding, in my mind, is pretty darn interesting.
Oh man, I'm really tired, bros.
Still trying to sort out
I don't know how much longer I'll be able to play. I'll be honest.
We talked about the apparent extraordinary rigidity of the crust as would seem to be reflected in the ability of the crust to withstand gigantic impacts. We talked about cratering on the moon, the ratio of width to depth, and we learned that there seems to be a threshold at which the width of craters can continue to grow larger and larger, but the depth seems to max out somewhere around 3 to 4 kilometers. In fact, it was said in one of the articles we referenced that some of the larger mare basins, if you're standing at the center, you don't even see the relatively large mountain ranges that form the rings of the craters. So, that's an interesting phenomenon regarding the moon. Then we talked about some of the lunar transient phenomena, which seem to suggest activity. And what kind of activity? The assumption has been for years that the moon was geologically a dead object. But if that's the case, then how do we explain the lunar transient phenomenon? And we got into it, I think we covered it most. Maybe there was a few things to pick up the thread of our discussion. This was, this was published back in 1991. Okay, so this was Winifred Sawtelle Cameron, published in Sky and Telescope. About 200 of some 30,000 lunar features visible in telescopes have been recorded as lunar transient phenomena, or LTP, sources. Half have shown activity only once. Of the remainder, a mere dozen features contribute to 3/4 of all reports. One area, the Aristarchus Herodotus Schroeder's Valley, is responsible for fully 1/3 of the total number of sightings. Most LTP activity occurs along the edges of Maria, near volcanic features like domes, sinuous rills, and craters with dark halos or floors. But these regions, like the rest of the moon, have been considered geologically dead. So we did discuss that we did quote that, but it's a good place to pick up our discussion. So what do we attribute this to? Is it volcanism? Is it, if it's not volcanism, what could it be? We did see that there was evidence of outgassing of carbon gases, and water vapor. And we saw the one quote by, I think it was Farouk El-Baz, wasn't it? He said that if the observation is confirmed, are considerable. If water vapor is coming from the moon's interior, says lunar scientist Farouk El-Baz, this is serious. It means that there is a drastic distinction between the different phases in the lunar interior. But the interior is quite different from what we have seen on the surface. Well, we also discussed the density of the moon, and we discussed why that was anomalous. And essentially we learned that the overall density of the moon as a whole, 3.34 grams per cubic centimeter. Well, what's interesting about that? Well, that's pretty low density. And in fact, that is roughly the density of the normal rock you would pick up on the surface of the Earth, and the density of rocks, basaltic rocks, picked up on the surface of the moon. So, what this is implying is that the material forming the surface doesn't seem to be less dense. Well, let me turn it around. The material forming the interior of the moon doesn't seem to be more dense than the material forming the surface of the moon. Now, how do you explain that? That's one of the things I've been puzzling over for a long time. How do you explain this uniform density? Now, one could assume from that implies that the moon as a whole is a homogeneous body. But then that raises difficulties in itself, which we'll come back to in a few minutes when we start discussing mass cons. You know, we're at the point of Apollo 11 convinced that there was really no water because they didn't see the hydrous minerals that one would expect to find. Those that contain OH radicals in the samples. So then, they believed, so was John W. Freeman Jr. and H. Kent Wells of Rice University in Houston that announced what they believed that they had detected water vapor on the moon using the suprathermal ion detector experiment. We talked about that. The SIDES, which is the acronym SIDES, have been quietly monitoring clouds in quotes of low energy ions during the lunar day and before sunrise and sunset. Okay, ions thought to escape from the Earth's magnetic low shock wave and ions from man-made impacts, lunar landings, and liftoffs. But then, it was on March 7th that the instrument saw something unusual at the 14th site. Let's see, that would be right here. A very high flux of ions in the spectrum predicted for water vapor. Apollo 12 SIDE also detected the ions. The flux of 783 counts per 1.2 seconds was much higher than anything seen before. More than 100 times greater than that detected when the lunar module vented. Another unusual aspect of the detection was that the flux occurred at the same time that swarms of moonquakes were detected. Rumblings that lasted from 12 to 14 hours. The ion occurrence began shortly after the moonquakes began and stopped shortly after the quakes ceased. Freeman speculates that water vapor could have come from a fissure created by the quakes. And, says Hills, the findings would not contradict the lack of water material found at the surface if the vapor were coming from deep within the interior. Well, then, as Farouk says, that would be considerable. What in the world does that mean if there's water inside the moon?
Well, the question comes is how is it forming? Where's the water and where are these other volatiles coming from? If we have carbon, hydrocarbons or carbons being formed inside, can the moon be geologically dead?
It would seem not.
Raises the question.
Right. I'm going to pause for just a minute to talk about our partners over at SHPO, who may save you a significant amount of headache in your day-to-day business. We sell a variety of geometry tools and models, like our beautiful atomic solids here at Randall Grossman LLC. When it comes to managing shipping, e-commerce, and returns, we've been using SHPO for over 4 years. they seem to be concentrated around certain features. One in particular was the crater Aristarchus. The Apollo 11 command module had just achieved orbit around the moon when the Mission Control Center in Houston, Texas received word that amateur astronomers reported transient phenomena in the vicinity of the crater Aristarchus. Asked to check out the situation, astronaut Neil Armstrong looked out his window towards the Earth-lit region and observed, quote, an area that is considerably more illuminated than the surrounding area. It seems to have a slight amount of fluorescence to it. Let's look at fluorescence. Let's look into that a little bit. Let's look up fluorescence and see what did you learn about fluorescence.
Well, you're looking at something that is going to be a lot like your fluorescent light. It is illuminating based on some sort of arc, usually, or there's some sort of chemical, electrical cause. So real quick, some fluorescent material examples here. Hold that up. We're going to have something that looks, usually when you're talking about TLPs, it's a red or an orange fluorescent light. Now these are rocks, okay, these are people, fluorescent.
Those were people. Not
Correct,
rocks.
those are people, correct. Matloline, I guess, is the fluorescent substance in the wood of the tree. I'm not going to try to pronounce that one. I'm going to move forward. But when you're looking at something that is fluorescent, it is going to be usually lit electrically or chemically. So, where are we getting that light on the surface of the moon?
Well, that's what I'm wondering. Why are we
Is it electrostatic? Is it electrochemical? Or is it an arc? Or is it volcanic? Or is it something else?
Well, I don't know, but I'm getting awfully darn curious about this whole thing.
None of this should really be happening unless, of course, the moon isn't geologically dead. And I think that's something that, if you want, right now we can pull up that video from NASA. They actually did a little bit of research here, and we're going to look at some geological evidence on the moon for specifically why the moon may not be as dead as we think.
2 years ago, we reported evidence that the moon is shrinking. Now we've found evidence that the moon is actually being pulled apart, forming features called graben. So the shrinking moon, it turns out, is not shrinking everywhere. Some places the moon is actually expanding by a little bit. So finding these young graben was a real surprise because we thought, well, all these low-base scarps are telling us the moon is shrinking. So what are these little small graben that are telling us the moon is pulling apart doing in this picture? How does this all fit together? All that's related to how the moon has evolved, how the moon has lost heat over its 4.5 billion year history. Most of the terrestrial planets, when they formed, were very hot, and they got so hot that they actually completely melted. When that happens, they will be in a general state of contraction because they're still hot on the inside and cooling down, and as they cool, they want to shrink. Only the outer part of the moon melted, forming what is called a magma ocean. And in that model, the balance of stresses or forces that are acting on the moon would allow us to form both these small lobate scarps that show contraction as well as these small graben that show the moon being pulled apart. One of the really, really exciting returns of the Lunar Reconnaissance Orbiter mission is that we've seen this now growing evidence of very young geologic activity on the moon. Many, many people have felt that the moon is pretty much geologically dead, and what we're finding is that that's totally wrong. That the moon appears to be geologically active now.
Interesting.
Yes, and I hope second Artemis mission doesn't get pushed off too far.
Me too. Me too. NASA keeps getting axed for no good reason.
For no good reason.
But that is interesting because, again, until recently, until the LRO's mission, we really didn't think that the moon was geologically active. Now, if there is a hot core on the moon, that immediately throws a huge question because is the moon homogeneous if it has a hot core? By definition, it can't be.
It can't be.
It can't be that 3.4 number in density. It can't. It can't.
Well, if you have a denser lunar core, the denser the lunar core, the more mass there is in the core, the less mass there has to be between the core and the surface.
Correct. Because we actually have the rough weight of the moon calculated, the rough mass.
Yeah.
So it's 73 million.
I think it was 73 trillion.
Trillion.
Yeah.
Yeah. Heavy.
Yeah.
73 trillion kilograms, right? Was it kilograms or pounds? Remind me.
I think it was tons.
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 73 trillion tons.
Yes.
Look that up. Yep. 73 trillion kilograms.
Kilograms.
73 trillion kilograms. This is a lot of kilograms.
Yes.
So, with that said, if we have a hot internal core and our mass at the surface is roughly 3.4, it would have to be 3.4 the whole way through. There's something going on in the moon. And so there's a few different explanations. Longitudes, but also that doesn't account for impact craters.
Right. So, we should talk about the mass cones.
I think we should, because that rolls right into mass cons. Because the moon's not homogeneous. What is a mass con, Randall?
Well, that's a short.
Wow, that's so dumb, man. Sorry, buddy.
For the term mass.
That is so dumb.
Concentration.
That's really dumb to hear, man. I'm sorry, buddy.
Mass cons, which are lunar mass concentrations. The lunar orbiter missions have provided both high-quality photographs of the moon and supplementary scientific information concerning the gravitational field of the moon. Previous investigators have concluded that the moon was gravitationally rougher than anticipated. Something else that was not anticipated. The roughness of the moon has been of interest to the Apollo project because of the resulting perturbations on the trajectory of the Apollo orbiting spacecraft. For these reasons, a new analysis has been done with the use of the accurate tracking data received here by the NASA Deep Space Network, operated by the Jet Propulsion Laboratory. We now report that this new processing of the lunar orbiter data has produced unexpected results. So this is back in 1968. Now, there's been nothing in the ensuing decades that has debunked any of this. I mean, the mass cons are fully accepted as being real on the moon, still are. I don't think the explanation, nobody's settled on the explanation for mass cons. Let's look a little further into it here. The study of local accelerations on the spacecraft resulted in a gravipotential map of the lunar near side, which has revealed very large mass concentrations beneath the center of all 5 near-side Maria, which is Imbrium, Serenitatis, Crisium, Nectaris, and Humorum. In addition, they were observed in the area between Sinus Estium and Sinus Media and Mari Oriental, or Oriental. The large rate of change in the accelerations over these mass cons reveals their relatively small physical extent, which is 50 to 200 kilometers, which would be about miles wide to 120 miles wide. In fact, analysis of the detailed computer results indicates a non-spherical trough-like mass distribution, approximately 50 by 200 kilometers, running generally east-west in Imbrium and Serenitatis. So, literally, what happened is as the lunar orbiter is going over the surface, there were points where the gravity of these mascons was so strong that the lunar orbiter dipped. It actually took a dip in its orbit.
Terrifying for them.
Probably so. Then, even though we have computed both masses and depths for the largest mascons, nevertheless, our present quantitative data require further refinement. One may easily compute approximate masses from an assumed depth, such as 50 kilometers. Okay, so they're assuming for the purposes of calculation that this whatever.
Sorry, man, that really sucks to hear, dude, about Iran.
30 miles deep. The Mare Imbrium mascon yields numbers of the order of 20 times 10 to the negative 6 lunar masses. Well, you don't need to worry about that too much. It just means, negative 6, which is 1 millionth, 20 times 1 millionth of the lunar mass. Well, this translates to us, as it says here, a spherical nickel-iron object about 100 kilometers in diameter would be a rough equivalent.
That's a bruiser of an impact.
Well, yeah, so a spherical nickel-iron object, 100 kilometers, that's 60 miles in diameter. So what they're saying is that it looks like a 60-mile diameter, something extremely dense, is embedded just below the surface of the moon.
Now, is that from an impact? Is that from an impact, or is that from something else? How is that there?
How is that there? Well, let's go on. Does each of these mascots represent an asteroidal-sized body which caused its associated mare by impact? If not, simply the original impactor itself, by what processes were they formed in the lunar interior? Is the presence of these objects consistent with a molten lunar interior? Well, if it's molten, let's go on here and dive into some of the physics of it here. I'm going to show you a map of, this is a lunar gravity map. Contour lines show the gravity strength above the mean value of the moon in units of 100 milligauss. Right, so this is the near side, and each of these is a Maria. Yeah, there we go with the labels: Mare Imbrium, Mare Humorum, Mare Serenitatis, Mare Crisium, and Mare Nectaris. If you would be so kind, would you pull up maybe a high-res photo of the moon? So here's Mare Imbrium, this really big one. Mare Serenitatis. Mare Crisium right over here on the edge. Mare Tranquillitatis here. Mare Fecunditatis there. And there's Nectaris. So we got them labeled right. We just didn't have them all. There's Mare Nubium, Mare Humorum. This is Oceanus Procellarum and Mare Imbrium. So there we go. Those are the Mare. And they're almost all on the near side. Let's see, there's one on the back side. I don't know if I have that. There it is, right here. So, if these were produced by bombardment, which presumably they were, this seems like it would have been a large flux of objects, very large objects, slamming in to the near side of the moon. Now that's interesting to think about. How do you explain that? And if it's the near side of the moon, then if there was a large flux or a flux of these large objects approaching the moon and slamming into the moon with this concentration of impacts, because presumably, what do we got here? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 8. And then that's probably 9 if you include Oceanus Procellarum. Well, now we're talking about 9 huge objects coming at the moon, assuming that all of the collection of these objects moving through space didn't all hit the moon, right? There must have been objects that flew by the moon without striking it. But that means if it's the moon's lunar face towards us, well then that means that the Earth itself would have had to have been in the pathway of these objects. Right?
Right, and those would be, you wouldn't think that those would be oblique angles, those would be straight on because of the formation of the craters, the way they're set. You wouldn't think it would be, because you would have a round impact in the dispersion as opposed to round impact sites. So you wouldn't think they're coming in at strange or odd angles. Those look like direct hits. If they're caused by impact events.
But if they're not caused, well, then what could they be? I mean, you would think that the mass cons, well, do we assume that those are the remnants of large impactors?
That's the current version that I've heard. I'm not sure if it makes sense.
Well, and here's this, like this is one of the Mare Serenitatis. Serenitatis, yes. And you can see how shallow it is. Right?
Yet there's what below the surface of some of these? We're talking 60 or 100 kilometer wide.
Yeah, so that's 60
nickel.
miles, being a rough equivalent. Not this, it being a rough equivalent,
It's
doesn't
100
necessarily
kilometers,
mean
yeah.
that, it doesn't necessarily mean that it's spherical, but that's what it's saying that's rough equivalent would be a sphere. Up to 60 miles in diameter of some dense material. But
And
let's go
again-
on because it is the. Okay, so let's see.
And again, you've got that dense material in one, all consolidated in one space. You have the assumption of something that is equivalent of a 100 kilometer sphere of nickel. The density is not 3.4.
Nickel iron.
Nickel iron.
No. The density is nickel iron. While I'm getting us back to where we were, pull up nickel iron. Let's see. I mean, that's got to be what? 6, 7?
So it's 8.94 is nickel. So let's see what it is with nickel iron. 8.7 for a nickel iron alloy.
Okay, so that's much more dense than the moon itself.
So at 8.7 grams per cubic centimeter, that way offsets the 3.46 assumption.
Yes.
Being homogeneous, it has to be homogeneous. It's not even taking into account 100 kilometer wide effectively.
Right.
So where's the mass? That's what we're asking. It's like the little lady in the Wendy's commercial. Where's the beef?
Where's the beef?
So here's the vertical acceleration at the lunar surface for the LP165P gravity field. Accelerations are the radial component at the lunar reference sphere with radius 1,738 kilometers. The near side on the left includes coefficients to degree and order. The far side on the right displays terms to only 1 degree and order 60 in order to limit noise in the image. Anyways, well there you can see that the Mare are concentrated on the near side. They're associated with Mare, which we just saw are all concentrated on the near side, which creates quite a remarkable differentiation between the two sides of the moon. So then, after that, there's a commentary here by J. Gordon Stipe. It was this is what he says, the discovery by Muller and Sogren of mass cons in the moon is of great interest. My investigations allow a calculation to be made of the size and depth of the mass cons in terms of the size of the mare formed by low velocity impact of an iron meteor. And of course it would have to be low velocity because if it was not low velocity, the object's going to vaporize. Okay? It says, I'm currently completing an analysis of penetration and cratering of concrete and soils by steel projectiles. I shall extrapolate these relations to craters the size of the largest lunar mare. This involves extrapolation from the largest craters in concrete, about 2 meters in diameter, to mare a few hundred kilometers in diameter. Ronka described the possibility of magma formation by cratering. And his figure 1 can be used to find the depth of penetration in the Earth needed so that the resulting pressure release at this depth would lead to melting. Because, you know, as you go down in depth, the temperature goes up. But what prevents the melting is the overlying pressure. So if you remove that pressure, let's say through an impact event, you now have this pressure relief melting. The material, the magmatic material then will upwell. This is typically why, for example, some geologists have proposed that the Yellowstone mantle
oh my God, come
might
on.
have been formed
Please.
by a large
Please.
impact of a rapidly moving iron object coming in relatively
Please.
perpendicular to the Earth's
No.
surface at the point of impact.
How did I fuck that up?
Punch a hole right through the upper crust and exposing the mantle. The upwelling of the magma plume was then the result of this pressure relief mechanism. So he goes on here to say, let's pull it up here. These results suggest that the lava-filled mare were formed when very large iron objects struck the surface of the moon at a velocity so low that there was no immediate fracture of the object. Now, how do you explain that? It's moving so slow, the impact produced a very large crater, and the object penetrated to such a depth that deep material was melted by pressure release and flowed to the surface to fill the crater. The interior of the moon must have been solid when these events occurred, because otherwise the dense iron meteorite would have sunk into the molten material. Does that make sense? If the interior of the moon is molten, and you've got this 8.7
grams per cubic centimeter, yeah.
8.7 grams per cubic centimeter, that's not going to sit there on the top of molten material. It's going to sink into that molten material. And it's going to keep on sinking until either it melts or it comes to a density roughly equivalent to the density of the object. At which point it would cease its descent towards the gravitational center of the moon. So what that's telling us is that the interior of the moon must have been solid and not molten when the mare formed. Now, okay, now we're trying to square that with interior volatility of the moon. Remember, there was something else we learned in our last episode. I think we were talking about the echo phenomenon in the moon.
The moon rings like a bell.
The moon rings like a bell, yes.
So
It's
that
staggering.
it kind of contradicts with this current theory
Well,
that the moon would be solid.
let's keep going here. The suggestion by Muller and Sogren is very reasonable. However, the depth of the mass cons, which they take as 50 kilometers or 30 miles, seems to be considerably underestimated. The depth of an impact crater measured to the bottom of the shattered material in the crater is approximately 1/4 of the crater diameter. This means that if the mare are filled craters, depth of Imbrium, for example, is about 300 kilometers, and the depth of Humorum is about 100 kilometers. Or in other words, 180 miles, or 60 miles. Those are some really damn deep craters. Because how wide is Humorum? Well, if it's 4 to 1, then Humorum has got to be 1,200 kilometers wide. And the depth of, Imbrium, not Humorum, Imbrium, would be 4 times 300 kilometers or 1,200 kilometers wide. Right?
Yep.
And given, so anyways, if the mascons are deeper, as I
Come on,
suggest,
boost me, one more boost.
then they must also be more massive to produce the observed gravity anomalies. Because the deeper they are, the smaller can be the gravity anomaly. If you took that mass all the way to the center of the moon, there would be no gravity anomaly.
It'd be a homogeneous mass at the center of the moon, as opposed to a mass cone.
As opposed to a mass cone. Yes. All right. I'm perplexed here. So, 300 kilometers, that's, like I said, that's 180 miles deep. Given the assumed size of the impactor and the width of Imbrium. Yet the damn thing is only about 4 miles deep. So then the suggestion is that lava came out and filled the crater. Okay, well, if the impact, but here's the problem as I'm seeing, if the impact is able to produce that much lava, I mean, you can calculate the volume of lava if it's filled that whole crater, wouldn't that completely destroy the impactor itself as well?
You would think it would actually reduce the amount of concentration of mass because you're going to have a hot ejecta.
Yeah. Yes.
That's going to consume the nickel iron impactor.
Consume it. Yes.
So, and again, none of this squares with a 3.8 grams per cubic centimeter homogeneous mass for the moon.
Okay, so then also we have the journal Science was running, this was a lot of these lunar results were new at the time back in 68. So this is by John A. O'Keefe. He was a
I might do one more run. One more run and then I'll probably sign
He's
off.
talking about this work of Miller and Sogren. So Miller and Sogren performed the astonishing feat, let's go here, of providing a relatively detailed, though preliminary, gravimetry of much of the front surface of the moon. The data from which they worked is in no sense marginal. The perturbations of the orbiter satellites which they used are so large as to have been an operational nuisance before they were understood. The interpretation suggested to Muller and Sogren by the papers of Harold C. Urey and tentatively adopted by them attributes the mass excesses in the Mare regions to mass concentrations, perhaps remnants of colliding iron asteroids of the order of 100 kilometers in diameter buried under the lunar surface. However, you got a problem there. On the other hand, both observation and experiment indicate that impact at normal meteor velocities leads to the scattering of the impacting mass as a result of shattering and vaporization. So normal meteor velocities, an impact at normal meteor velocities leads to a scattering of the impacting mass as a result of shattering and vaporization. Even if it is supposed that the circular mare were made by bodies already in orbit around the Earth, and hence having relative velocities of only a few kilometers per second, there remains a difficulty in supporting the mass.
That was my best gate of the night. That might be my run of the night. I think that's over.
8 kilobars, or 110,000 pounds per square inch. this exceeds the crushing strength of granite, it is reasonable that a mass of this kind would crush its way to the center of the moon. The analogy I've kind of used is, imagine you have a bowl of pudding and you have a lead bullet and you place it on the pudding, and it's going to slowly sink right to the bottom of the bowl, isn't it?
Yep. Or shoot it at the bowl of pudding and see what happens. Or throw it at least.
Well,
It's moving fast.
right. But in this case, they're trying to slow it down so slow that there's no shattering of the object. And he's saying here that even a couple of kilometers per second. I mean, what's kilometers per second? A kilometer per second, you're looking at 3,280 feet per second times 3,600 gives you a lot of feet. Let me divide that by 5,280, and you're still talking over 2,000 miles per hour. So the object, even at 2,000 miles per hour, boom, it's going to shatter, and the mass of the impactor is going to scatter because of the shattering and vaporization. And the end result would be no mass con.
Correct.
So how do you do that? And if it didn't shatter and remained intact, well then it would, given 110,000 pounds per square inch, this exceeds this. I mean, this is way beyond what would cause granite to completely crush. So then it says it is reasonable that a mass of this kind would crush its way to the center of the moon.
I don't think this model of an asteroid impact creating the Mares is a good model. Doesn't seem to pan.
Yeah. Well, let's refer back to the paper by Harold C. Urey, which was also published in Science, 1968, and in December of 1968. And Muller and Sogren have concluded that there are very massive objects in certain locations at the surface of the moon. These mascons, as they are called, represent a non-isostatic condition in the surface of the moon. Let's pause there for a second. Remember, isostatic is the vertical adjustment of a body. Earth, moon, doesn't matter. This is it's a non-isostatic condition. Because an isostatic condition would require that these objects, like we just learned, should descend towards the moon's center of mass. These mascons represent a non-isostatic condition in the surface of the moon. If the Mare Imbrium situation is taken as a prime example, because it exhibits a maximum effect, we come to the conclusion that the viscosity of the moon must be higher than that of the Earth by a factor of 10 to the 4th. In other words, 10,000 times higher than that of the Earth. It is difficult to devise a lunar history which provides the low temperature required to account for the lack of isostasy and the low electrical conductivity, and at the same time for melting processes required to produce the basaltic material on the surface of the moon. So the viscosity of the moon must be higher than that of the Earth by a factor of 10 to the 4th power, which is 10,000 times greater than the viscosity of the Earth.
There comes that several orders of magnitude denser outer surface of the moon than the Earth.
Yeah. Now, let's jump forward 11 years to 1979 after additional data and more studies have been conducted on mascots. This is by A.E. Ringwood in the textbook Origin of the Earth and Moon. This is what he says. At one time, it was naively believed that mascons are remnants of the dense projectiles responsible for the excavation of the basins. But it was soon realized that they would have been totally vaporized. Furthermore, this excess of mass brought to the surface of the moon in the first place? Right? Because if it's something to do with the layers of salt, and that's where the density origin is, and that's lying on top of lower density crust. You're now talking about you got to bring higher density material up to the surface of the moon, which is the exact opposite that lower density material higher density material should be migrating towards the center of the moon, especially if the moon is molten. Well, goes on to say, if a planet is in isostatic equilibrium, the overburden pressure will be constant at any given distance from the center of the planet, which we presume is like more or less the case with the Earth. Terrestrial continents are much thicker. Terrestrial continents are much thicker than the oceanic crust, simply because granitic type rocks have lower density, right? So the lower density rocks are rising up. The higher density rocks are sinking down. The large mascons of Imbrium and Serenitatis would certainly not have survived on the moon in isostatic equilibrium. They would have sunk without a trace. Perhaps the most remarkable aspect of mascons is their very survival. The fact that they still exist today implies that the moon's crust must have been remarkably rigid for a very long time. Remarkably rigid. So then,
Remarkably, being 10,000 to 100,000 times more rigid than the Earth.
what it's looking like. Now I'm going to jump all the way back to 1962 in the work of Gordon J.F. McDonald. It was published in the Journal of the American Rocket Society, the journal called Astronautics. The title of the paper is The Moon and Its Interior. So, this is quoting now from Gordon J.F. McDonald. Data relating to the lunar interior have been derived from astronomical observations. These data fix the mean density of the moon and provide an estimate of its gravitational figure. Now this is before the discovery of mass balance. The mean density is well established at 3.34 grams per cubic centimeter.
Something's blowing up.
This value is tantalizingly close to the density of a large number of silicate materials found on or near the surface of the Earth. Yet, the mean density of the moon presents a number of major problems. The abundance of the radioactive elements determines the internal temperature distribution of a planet. Urey, in 1952, pointed out that a limit on the possible temperature distribution within the moon can be derived by an indirect argument using the moon's gravitational field. If the temperatures within the moon approach the melting point of the silicates, then the figure of the moon should closely approximate that of a fluid with an equivalent density distribution. Got it? Let's go. If the temperature within the moon approaches the melting point of the silicates, which given the mass of the moon, it should easily approach and exceed that melting point of silicate rocks, right? Which he's citing this because they have roughly the same density as the moon as a whole, 3.34 grams per cubic centimeter. The physical librations of the moon provide an estimate of the ratios of the difference in moment of inertia to the mean moment of inertia. The ratio of the difference in the moments of inertia to the mean moments of inertia are much larger than would be predicted for a homogeneous moon in hydrostatic equilibrium. So look up moment of inertia. Let's define that for the listeners and also for our own clarification. I usually will use I will use an example, and it's an approximate example, but I will use oftentimes in lectures I'll say, okay, here's one way to help understand. Let's say we have a line here, and that is a diameter of a spherical object, and it's radially symmetrical about its center of mass. Its moment of inertia would coincide with its center of mass, and what that means is from an exterior view, looking at a gravitopotential map, this would appear the equivalent of a mass point, right? So if you're trying to turn this axis, this axial diameter, and it's only one point, it's easy to turn. Like what I'll do is I'll hold something up, I'll tell somebody, here's this pencil. Hold this pencil, pinch it as hard as you can, and prevent me from rotating. Well, nobody can do it. But then if I say, hold it in 2 points, now I'm going to try to rotate it, and you resist my efforts to rotate it. Well, now it's a completely different matter, right? In effect, you can kind of think of this as one moment of inertia and 2 moments of inertia, okay? So there's a difference between the mean moment of inertia and the actual moment of inertia. Now, what did you come up with for a definition?
So the moment of inertia, also known as the mass moment of inertia, angular rotation or mass, second moment of mass, or more accurately, rotational inertia of a rigid body is defined relatively to a rotational axis. It is the ratio between the torque applied and the resulting angular acceleration about that axis.
There we go. That's what I'm talking about. The torque, which is this, you apply a torque. So what's happening here is the Earth's gravity field is exerting a torque on the moon.
All right, this is the last one of the night.
We know something about the moon's rotation on its axis, though. It's
It is
perfectly
not 52
synchronized
days.
with its orbital period. All right. So going back to Gordon McDonald's article.
Yo, 50% finished. We're gonna end it with that Alex Jones clip, man. This one end this night with. Oh, nice, brother.
He goes on to say, like the Earth, the moon is flattened at the poles and has a bulge all around its equator. Unlike the Earth, the moon also protrudes along the direction between the center of the Earth and the center of the moon.
The elite are all about transcendence and living forever in the secrets of the universe, and they want to know some are good, some are bad, some are mixed. But the good ones don't ever want to organize. The bad ones don't want to organize because they lust after power. Powerful consciousnesses don't want to dominate other people. They want to empower them so they don't tend to get together until things are really late in the game. Then they come together and evil's always defeated. It's good, so much stronger. And we're on this planet, and Einstein's physics showed it, Max Planck's physics showed it, all there's at least 12 dimensions. And now that's all the top scientists and billionaires are coming out saying it's a false hologram. It is artificial. The computers are scanning it and finding tension points where it's artificially projected, and gravity's leading in to this universe. That's what they call dark matter. So we're like a thought or a dream that's a wisp in some computer program, some God's mind, whatever. They're proving it all. It's all coming out. Now, there's like this sub-transmission zone below the third dimension. It's just turned over to those horrible things what it resonates to. And it's trying to get up into the third dimension. That's just a basic level of consciousness to launch into the next levels. And our species is already way up in the fifth, sixth dimension consciously, our best people. But there's this big war trying to like basically destroy humanity because humanity has free will, and there's a decision to which level we want to go to. We have free will, so evil's allowed to come in and contend, not just good. And the elites themselves believe they're racing using human technology to try to take our best minds and build some type of breakaway civilization where they're going to merge with machines, transcend, and break away from the failed species of this man, which is kind of like a false transmission because they're thinking what they are is ugly. sources, that they wanted to build a giant artificial system. And Google believes that the first artificial intelligence will be a supercomputer based on the neuron activities of the hive mind of humanity, with billions of people wired into it with the Internet of Things. And so all of our thoughts go into it, and we're actually building a computer that has real neurons in real time that's also psychically connected to us, that are organic creatures, so that they will have current prediction powers, future prediction powers, a true crystal ball. But the big secret is, once you have a crystal ball and know the future, you can add stimuli beforehand to make decisions that control the future. And so then it's the end of consciousness and free will for individuals, as we know, and a true 2.0 in a very bad way, hive mind consciousness with an AI jacked into everyone, knowing our hopes and dreams, delivering it to us, not in some PKD wirehead system where we plug in and give up on consciousness because of unlimited pleasure, but because we were already wired in and absorbed before we knew it by giving over our consciousness to the system, our daily decisions, that it was able to manipulate and control into a larger system. There's now a human counterstrike taking place to shut this off before it gets fully into place and to block these systems and to try to have an actual debate about where humanity goes and cut off the pedophiles and psychic vampires that are in control of this AI system before humanity is destroyed. Humanity is only
control of AI? How do the pedophiles get in control of AI?
The pedophiles at a whatever level, the devil, whatever you would call it, is their dimensional thing that gives them advanced off-world technology. The fallen one is not this world, is giving them advanced knowledge on how to construct these systems that have already been used before on other populations.
What? That's Satan? What are you talking about?
Let's say,
Explain that. You say
something
something.
that, the stupid preacher tells you about is totally controlled, or something you read about, in the news or TV.
Right.
But this is an interdimensional force that wants to influence us to build something that absorbs us and kills us, rather than the divine free will we're given to build something much better that empowers the species. So the species is now making a decision about its entire future.
Where are you getting this from?
That's what it is.
But where are you getting it
I
from?
know, from looking at all the data, researching it, studying it, watching the enemy. That's the big decision that humanity has now got before us.
Four viewers, thank you, 4 viewers, thank you. 5 viewers.